That's on the internet forever.
Well, yeah. Let's be honest, no one watches this.
That one's gonna
some
blow
kids
up
do.
with 5
Until you
million
go
views.
viral.
Some kids do. What'd you say?
What if that one just blows up with like 5
Yeah, that
million?
would be silly. It'd be hilarious.
All right. So, yeah. So, immigration, emigration. Now, when we talk about, and we're going to talk about the law of 70 and the doubling time in population, we're going to do that today. We kind of, and I just say, let's ignore that, which is, for some countries, like our country, you really shouldn't. But it's kind of too hard for me to find exact numbers and stats on that or data. So when we're talking about population growth, we focus a lot on births and deaths. So that's just a lot easier for the class to just understand the concept. But these definitely play a big role in how population changes over time. So if you were to, if I was to give you all of the data, so how many people immigrate every year, how many people emigrate every year, the crude birth rate for a year, and the crude death rate for a year for a year is redundant. If I gave you the crude birth rate, which is a year, crude death rate. So if I gave you all this information, could you come up with just a generic or quick equation? How would we figure out how the population is going to grow or decrease?
Births minus deaths.
Okay, births minus deaths, that's good. What about the other two?
Plus
Immigration minus immigration.
So what two of those would we add together?
The birth
Immigration and crude birth rate.
Immigration and birth rate would be added together as one
Subtract.
number, and then what we would add death and emigration, that would be the other, right? Because you'd have your two positives and then your two negatives, think of it that way, right? Positive meaning contributing to more people, negatives taking away. So once you get done with this, the next slide is showing exactly what we just said. You can treat human population as like a system, and you have inputs and outputs. Your input is your immigration and your crude birth rate. Your output is emigration and crude death rate. So you guys, I think, probably knew these terms already. This might be new to you as far as crude birth rate. So birth rates, death rates, you might have heard of those phrases at some point in your life. But specifically, this is one or out of 1,000 people, and out of 1,000 people. It's just easier to manage the numbers when it's 1 out of 1,000 or 2 out of 1,000 instead of individual people. Okay, so there it is. So just get this down, or at least understand it. You don't need to copy it word for word. That the inputs into a population, and again, immigration doesn't really work if you're talking about the globe, right? But if you're talking about the United States or Japan or whatever, a specific country, your immigration and your births will add to the number of people, and emigration and deaths will take away. Let's see here. So in 2017, so I have some stuff to add here that the slides don't show. Global population increased. Global population increased by 12 people per 1,000.
Is that 1,000 like including males and females?
Yes. Yep. 12 people, yeah, just people in general. So the crude, so CBR, did they abbreviate that in the previous slide? Yeah. So you're going to see CBR and CDR a lot. We're not, you're not going to really see crude birth rate, crude death rate written out very much, like in the book or even on the test. I would think on the test, sorry, first time around here, guys. I would think though on the test they would spell it out for you, but they might not. So you need to know CBR and CDR. That's what that means. Like TFR, we're going to learn today, total fertility rate. That's an important acronym there, abbreviation. All right. Anyways, CBR 2017. CBR was 20 out of 1,000. So the way I'm writing that really isn't accurate. It really, I'm just spelling it out for you. It's 20 out of 1,000, but technically CBR is just 20. It's already assumed it's out of 1,000 people. So you won't see that. I'm just writing it to help you understand the actual number there. But it's 20 out of 1,000, and the CDR was 8 out of 1,000. So again, let's think of a mathematical equation. How could we take these numbers and calculate global population growth as a percentage? So that's the next step. So understanding these two things contribute to increase the population. These two decrease the population. So again, ignoring immigration and emigration, especially because we're talking global here, so that doesn't factor in. So if we know this one, so again, that's like the positive and this is the negative, but we want a percentage. So I just want you to think about it for a second here. Can I erase this? Okay. So I want you to just think about it here. Maybe talk to somebody. How would we figure out the global population growth? So from now on, when we say population growth at any point in this class, we mean a percentage. So global population growth, how would we take those two numbers and turn it into a percent? Well, yeah, take a couple minutes, talk to each other, come up with a percent. What do you think?
Okay, so what you do is you take 20. You take 20. You take 20. You subtract 8. You take this and you shrink it. So I have 1,000.
There's actually two ways to do it. I'll give you the way the book shows it, but there's two ways.
Percentage.
Yeah.
I know.
Crap.
Hard being
You need me to keep it.
That's hard being
All right, I'm gonna come around and I want you to show me your percentage.
good.
Oh, wait,
Wait, what?
Write it down somewhere.
No.
I'll give you another minute. I'm gonna go grab my egg whites.
You put like salt in that many?
Salt,
The devil's spice. So, yes, the cheese with it, or?
No, I forgot a fork too, so I guess my fingers are gross.
You should make it all Yolks are better.
It's like delicious egg whites.
Yolks are better.
I love eggs. I eat so many eggs that I get worried about cholesterol, so I eat egg whites to kind of replace it. I eat probably, I don't know, somewhere between 15 and 18 eggs a week. I make eggs and egg whites every morning.
So what you have your eggs in the morning? Toast.
Peanut butter toast, peanut butter
Crunchy?
toast, eggs.
Crunchy peanut butter? Just like
It's just like regular peanuts. No,
it's
no.
good. Like
It's
crunchy
pretty
peanut
good.
butter.
I grind peanuts at the store.
Oh my gosh, I had
So-
medical bread.
No, but yeah, same concept, right? Yeah, so you just put the peanut, they're in a grinder, you just push a button and then you do peanut butter. Anyways. And then, alright, let's see. Ketchup. Are you in eggs and ketchup?
Yes, I love it.
Yeah. I've seen it done. I've done.
What about hot dogs?
I've done.
Raise your hand if you put ketchup on hot dogs.
Oh, yeah.
Raise your hand if you like 50.
I hate hot dogs.
Wait a second, no. If you put ketchup on hot dogs, you have to get out of my classroom. That is an abomination. Hot dogs are
Yes,
disgusting.
yeah.
It's disturbing.
Mustard,
Mustard, like, oh, no.
No.
Forget American humans, normal humans.
How
would
is
eat
it so
mustard.
cheap? Little pigs step in.
I don't like hamburgers.
I hate ketchup and mustard.
Yeah, like.
Nah, ketchup, I hate
If
mustard.
Will's an
advocate for how
But like
hot dogs are
disgusting.
unhealthy. We all know it. We're still gonna eat them though.
No,
They're
I just,
disgusting.
I just like.
It's not just knowing what's in it. I think it tastes gross.
I don't like the way everybody.
But this is coming from a guy eating egg whites with his hands.
Until you reach like the age of like
Wait, you eat hot dogs?
35.
No, so
You start putting ketchup on your.
my buddy,
or
my
mustard.
wife's friend's husband, kind of a friendish, whatever, acquaintance, he said, once you reach the age of like 12, you have to stop putting ketchup on your mustard.
No.
Or
No.
on your hot dog.
No, it's
No.
No, it's not 12. It's way older.
25, 30. Like, then you.
So what if you see like a 50-year-old dude putting ketchup on a hot
They
dog?
do weird.
That
That's
weird?
weird.
Okay, so
Do
you're
the nod.
weird.
Do the nod of respect. to
It's
each
so
other.
not weird. You like what?
Alright.
Yeah.
Those
Like,
kids
you're
go
so
to
American.
Ours is not.
Well, if you do both, but really it should just be
There's always
mustard.
ketchup with like hot dogs.
I know, but that's society's fault. So that's not your fault. That's
What
society
do you
putting
eat
that.
ketchup with? Like French fries?
Sometimes.
He doesn't eat French fries.
I mean, I rarely eat French fries, but sometimes I
Put it on
do.
your hamburger.
Tonight I'm going to
Wait,
dinner
alright.
with my uncle,
So
and
you,
I'm
like, not
going
use
and I'll
ketchup
eat
at
like normal food.
Alright, take
Wow.
some, take some
Way.
whole
Not
grain,
quinoa?
fresh cut fries fried in like peanut oil or something. Sweet potato. What are you gonna
Sweet
have?
potato fries. Those are the
Those are
best.
so good.
Alright, the answer is
What do
1.2%.
you put on your or on your
Hot-
hamburger?
How?
Hamburgers, mustard.
Wait, so you don't
What?
like ketchup?
Wait.
That's
If it's a plain, just a plain,
Like cheeseburger.
like if I'm at someone's barbecue or whatever, and they don't really have a lot of side stuff, I'll just have a plain burger with mustard. But if
No,
there's-
you're
I would
right.
prefer to have cheddar, so cheddar cheeseburger with lettuce and tomato.
I like
Yeah.
That's what I
So,
prefer.
are you one of those guys that if you're just given a hamburger, you don't eat the bun?
Oh.
So if I'm
Oh my
making
God, you know
burgers,
lettuce
if I'm
fries?
making burgers at my house, I don't use
You have the
buns.
lettuce
If
bun.
I'm
Yeah,
going
the
out,
lettuce
if I'm going out to a
I'm not
restaurant,
going to your house
I'll eat the
probably.
bun.
What do you make? What, do you use like
He
lettuce
asks
buns?
for them.
I have, but I'll just eat it just to eat.
Yeah.
So it's not a hamburger. It's a beef.
It's just a
No.
meat patty. Alright, this is all being recorded, which is ridiculous. Back to this. So the answer is 1.2. Now there's two ways to do this, so stay with me. Population growth. So write this down. I'll use the numbers as examples that I gave you, but you can do it with any number as long as you know the CBR and CDR. So population growth for this one be 12 minus 8 over 10 times 100. Now, wait a second.
Where'd you get 12? Where'd you get those ones?
No.
Where'd you get
No.
20 minus 8, right?
That equals 1.2%.
No, it does not. It would be 20. 20
20
minus
minus
8.
eight.
It's not 12 minus
Oh, sorry guys.
So 12.
Sorry.
And again,
Yeah, where are
where
they
did you
from?
get those numbers?
So I gave you 20 and 8. Your CBR is 20, CDR is 8. So stay with me. I'll explain it all. So this is your accrued birth rate. That's your death rate. If you subtract the death from the birth, that's how many people you have. Why are we dividing by 10? Because these numbers are really out of 1,000. So the other way to do this, or you could do 20 minus 8 divided by 1,000 times 100, if that makes more sense to you. Because you have 20 out of 1,000 people born, 8 out of 1,000 people that died, subtract that and divide, then multiply by 100 to get a percentage. Either way, it's the exact same math, it's the exact same concept. You take your births minus deaths, to get a percent, you're going to have to divide it by 10 because it's out of 1,000 people, or just do it this way. Either way, you do need to know how to do this. You need to know how to calculate population growth if I give you crude birth rate and crude death rate. So as an overall, I could write a generic formula here, CBR minus CDR. So I can just substitute those in. So let's try another one. What if I told you the, what was my other example here? The crude birth rate is, CBR is 22.8 and the CDR is 11.3. So CBR is
Didn't you have 22.8 out of 1,000?
22.8. It's an average.
Oh, okay.
And then CDR, what did I say? 11.3. There you go. Give me the population growth. fruit.
What's-
Then I'll have
What do
lunch.
you have for lunch?
Eat 'em all.
Chicken parm, quinoa, potatoes, and kale.
Sounds good. I love them.
It's a lot of calories.
Yeah, it's a lot.
What do you
And I'm gonna have a steak dinner tonight.
Okay. Hungry boy.
Tomorrow.
He's a growing boy.
Alright, what'd you guys get?
1.15%.
1.15, right. 22.8 minus 11.3 divided by 10, or you could do 22.8 minus 11.3 divided by 1,000 times 100, which is the same thing as divided by 10. Questions on that? Okay, next. Doubling time. So, you don't have to write this down, we just did. Alright? I didn't put immigration and emigration in there. I don't have a practice problem for that, but if they were to give you the data for that, you would just add the immigration to the births, and then the emigration to the deaths, and this is, I hesitate as a teacher to say this, but if you just kind of think about it, and I don't want to say use common sense, but if you think about a problem, if they give you one of these, and they do give you immigration, emigration, just remember what increases population, what decreases, and then I think you'll be fine. But you do need to remember that. CBR minus CDR divided by 10, that'll give you population growth rate. Now the doubling time is another equation, and it's very simple.
70 divided by.
70 divided by what we just learned how to calculate. So this will be on the test from what everybody told me. Alright, so you do need to understand this equation. It's just two numbers. It's 70 divided by the growth rate. And I know what you're going to ask, why the number 70? I did look into it, and I don't have a great answer, so I apologize. I'll look into it again. Maybe I can figure that out. I'm sure there's some algorithm somewhere that they did calculations, and they came out to a constant number, and 70 was that number. It's kind of like any constant in chemistry. Avogadro's number, or 22.4 liters in 1 mole of any gas. Like that, there were calculations and experiments done, and that number kept showing up, and that's how it became a constant. So I would guess that's kind of where that came from, but I don't have a great answer for that. All right, so doubling time is important. Demographers, scientists want to know about how many years they think it's going to take for a population to double in a certain country or the world. Why would that be relevant information?
Population increase. Gotta know how many people there's gonna be.
Why doubling though? Why is that significant?
Because twice what you get.
Okay, you see how fast it's growing? Right, and if you have double the population, you need double
The resources.
resources, right? So it's just an easier way to kind of say, all right, by this time, or by this year, we think it's going to double. So by this year, we need to double our resources, our food, water, whatever it is, territory, all those limiting factors. Density dependent or independent? Food, water, territory, air.
Density D.
Dependent, right. So that's why this is useful. All right, so take the numbers I just gave you, and if this was a specific country, tell me how long would it take to double the population. You don't need to know the population size. That's the cool thing about this. So you could have 5 million people, 1 billion people, whatever. Just take those numbers. Now you just figured out your population growth rate. You told me it was 1.15. Now tell me how many years it'll take to double.
So I'm thinking we have our. Yeah, it's 60. You gotta read the whole list.
By the way, this is called the rule of 70.
We don't know why.
Hold on. Yeah. So make sure you write this down too. Don't just write right under here, rule of 70, just because I can definitely see that on the test, them referring to it as, according to the rule of 70, how many years would it take for this population to double? And I don't want you getting confused, right? It's the same thing. Doubling time, rule of 70, same thing. All right, so anyways, you take 1.15. All right, I'm just going to abbreviate DT. Doubling time for this country would be 70 divided by 1.15. And what'd you guys get?
61.
About 61 years, 61 point something, right?
Well, it's 60.9.
Oh, it's 60.9. So about 61 years. All right, good. So now is that math problem much clearer? Yeah. So
The only thing that was confusing about
Yeah,
was
we
it
assumed
had
we got the
all
70
these
from.
other things, and then all it wanted was the double.
I know
Yeah.
it gave you a whole lot of information.
And
that
both the
you-
questions had the same growth rate, so it was the same
So
answer.
it was literally the same.
Oh, was it really? I
Yeah.
looked at that. I didn't think it was. It was.
Yeah,
Well,
both
that's-
1.5.
That's not very.
So we were like, it can't be that easy.
Yeah. Well, all right. Okay. I'm trying. You know what? This is really high. That's a really high number. I thought I wrote down the country I got this from.
Nigeria.
Yeah, but I think I told you yesterday. Niger is
Niger.
it has the highest population growth right now. All right, we'll take a break and let me see if I can figure that out.